Alright, on this paper, I've tried to put together some information about transformations, as you can see. So let's start by covering up some of this information for just a minute. So step number one, when you are looking at a set of data, is you want to see if it is linear. So you're checking to see, does the scatter plot look linear, and does your residual plot look scattered? If so, then that is fantastic. That means your data follows a linear model, and you can move forward with doing stat calc 8, getting your least squares regression line. You would have an R value that could help you describe the strength of your correlation, and your R squared would tell you how much of your Y is explained by your X. However, if you see that one of these two things or both of them is not what shows up on your calculator, then your data is not yet following a linear pattern, but we want to try to re-express the data so that it could be described as linear. We can model it as a linear function. So if it's not linear, we move on to step 2. Step 2 is to go straight to stat calc 9, 0, and A and do log, exponential, and power regression. You're looking for the R squared value that would be closest to 1. Whichever one that is, then you're going to move forward to the next step. And the next step is to transform your data. Get an appropriate model for that data. So in your calculator, we're going to take a look in just another second at a paper that'll help organize that. But you're going to take the log of X if you want a log transformation, meaning your R squared value was highest when you checked over here for the log. And then you would write out your least squares regression model in a linear format, but put log where you've taken log. So you would write y hat equals a plus b log x, and those come from your calculator. Exponential means you take the log of the y. So when you write out your model after you've done stat calc 8 using your transform data, you just need to make sure you write log where you took log from your calculator. For the power model, you need to take log of x and y. So that would mean the power regression gave you the highest R squared value, the one closest to 1. But when you write your least squares regression model, you just need to make sure you put log on x and y, because that is what you did in order to get that to become a linear model. You had to re-express your data. But remember, you always use stat calc 8 to get a least squares regression model. It's just that you might be using some transformed data to enter in there because L1 and L2 needed to be re-expressed. So keep in mind what you were doing, but then you're still using a linear model in the end. So I've tried to organize that on another page so you could take a look at what happens in your calculator. So in our calculator, we always put our data into the list. Typically we put our x's in L1 and our y's in L2. The next thing we would typically do, again, referring back to step 1 over here, is we'd want to look at our scatter plot. So we would plot L1 and L2 as a scatter plot and take a look. Yeah, that might look linear. Maybe it looks a little curved. So we need to look at the residual plot. It's always best to look at both. So then in your calculator, you would go to your residuals, but remember to do stat calc 8 first. We've looked in class about how sometimes that'll have old data in your calculator. So do stat calc 8 for L1 and L2, and then fill up your residuals in L3, and you're able to look at your residual plot. So you would go to your stat plot, and you would plot your x's and your residuals, and you would take a look. And you would check to see, is my scatter plot linear? Are my residuals scattered? If great, then you move forward with that, and you don't have to transform your data. However, if they did not look so great, they don't look linear, then you're on to transforming. So you would need to go ahead and put in whichever one is appropriate. So if you've decided log is appropriate, then I've just put a hypothetical here. Like let's say I took log of the x's and I placed those in L4. And I have log of the y values in L5. Then I have everything I could possibly need to do a transformation. So if that's my case, I've put them there, then I would take the log transformation, if that was the one I needed, and I would need to use L4 because that's the log of the x values, which goes with the log transformation, and L2, which are my plain old y values that have always been there. So those would be the two I would need when I type in stat calc 8 to get my linear model. But remember, those would be the data because it's log of x and y. If exponential was the one that I needed, then I would need the x values, just the plain ones that I started with, but I need the log of the y values. So StatCalc 8 would need to have L1 and L5 to get the right model, and I would just need to write it appropriately like we already talked about. And for power, very similar, you would use L4 and L5 because that's where the log of the x's and the log of the y's are now located, if this was my example. And you just need to write out your model appropriately. I think some of you in class were a little confused about this process, so I wanted to show you that you're simply doing the transformation and putting in the appropriate x and y's just depending on what you needed for your transformation, which goes back to your r-squared value. So back over here on this page, whatever r-squared value you found was the highest, closest to 1, then you would need to transform your data, still get a linear model, but make sure you're getting a linear model using that transformed data where appropriate, and write log where appropriate. The last point I want to make is if you want to plot a residual graph of your transformed data, make sure in your calculator you do StatCalc 8 first before you use the resid button that we've talked about. Otherwise it'll have those original residual values still in there where you checked your original residuals. So in your calculator, when you plot your residual graph, make sure your x value is the one that you're using. So like for log, that would be log of x, and then your residuals would be your y. For exponential, it's plain x because you never took the log of the x's for exponential, and then your residuals. And for power transformation, you would still need log of x, but also your residuals for that one. So that's just if you need the residual graph of your transformed data by chance. Make sure you've done StatCalc 8 for your new transformed data before you go get your residuals from your list. Okay, well I think that's enough for now.